Sampling is a process of selecting subset of observations from population to make inference about various population parameters such as mean, proportion, and standard deviation. Sampling is necessary when it is difficult or expensive to collect data on entire population. Suppose if you want to conduct some study on COVID-19 patients within India, it will be very difficult. Means so many COVID-19 patients are there now. So we can select some random people from this population and we can conduct the study on sample. From this sample, we can make some inferences about the population. It is an important step in inferential statistics since incorrect sample may lead to wrong inference about population. Here are the benefits of the sample. First one is reduced cost and speed. It is obviously less costly to collect selected subset of data rather than entire population. In sample, we no need to collect entire data of the population, so it will be easier to collect data and summarize. So it will be faster. If you take exit polls, speed of the study is important. Means you have to collect data fastly and you have to give the exit polls quickly. To understand the sampling process, let's see simple example. This example is taken from Business Analytics book by Dinesh Kumar. It is not 1973, it is 1936. In 1936 USA presidential elections, the Literary Digest conducted opinion poll. Alfred London was contesting against Franklin Roosevelt. Literary Digest predicted that London would get 55% votes and 41% for Roosevelt. However, actual votes polled were 61% for Roosevelt, 37% for Alfred London. Means here 20% prediction error was there. They took the sample size of 2.4 million. The main reason for such large error was because of sampling method they used. There were two major issues with sample. One is the voter names taken from telephone directory. They selected middle class and upper middle class voters since telephone ownership was rare in 1936. They contacted close to 10 million voters. However, only 2.5 million responded. Another survey revealed that 67% of Roosevelt supporters claimed they did not get called by the Literary Digest. The election result was correctly predicted by George Gallup. They took small sample of 50,000 when it compared with 2.4 millions. Observation here is larger sample will not improve prediction if sampling process is incorrect. So correct sampling process is very important. The following steps are used in any sampling process. First one is identification of target population. Suppose if you want to conduct some opinion poll, you have to conduct the study on the people whose age is over 18 years. Means they can only vote. If you conduct study on children below age 18, it may not give proper results. Second one, decide the sampling frame. Sampling frame defines the source used for identifying the people of the target population. In our previous example, Literary Digest used telephone directory as one of sampling frame, which turns out to be an incorrect sampling frame. Third one, determine the sample size. It is important since collecting data can be expensive. At the same time, insufficient sampling results in lack of precision in estimation of the parameters. Since large sample is expensive and a small sample might give more error, so you have to decide sample size such that it should be cost effective and should be confident enough results. Fourth one, sampling method. Sampling method is a technique used for selecting individual cases in sample from target population using sampling frame. It is classified into two major categories: probabilistic sampling and non-probabilistic sampling. Probabilistic sampling further divided as random sampling, stratified sampling, clustered sampling, and bootstrap sampling. In probabilistic sampling, the individual observations in sample are selected according to probability distribution. Assume that population has capital N observations. We are interested in creating sample of size, suppose small n. There are NCN different ways for creating such sample. Random sampling. Random sampling is one of the most popular and frequently used sampling method. Random sampling is used when population is homogeneous. In random sampling, every observation in population has equal probability of selection in the sample. If population is non-homogeneous, if you take our previous example, middle class people and lower middle class people, the telephone was there for only middle class and upper middle class people. For lower middle class people, telephone is not there. So if you use random sampling, in this case, if most of the observations come from this class, your results might deviate. So you have to use random sampling when your population is homogeneous, means it should have all similar kind of observations. Stratified sampling. This stratified sampling will be useful when population is non-homogeneous, means you have different classes in the population. For example, if we take COVID-19 effect on different sectors in India, suppose banking, healthcare, entertainment, and on some other sectors. If you take healthcare, it is benefited by the COVID-19 effect, means they make more profits. All other sectors might get into losses. Here we cannot use random sampling because random sample randomly select some observations from all these classes. So if more observations comes from this healthcare, it does not reflect the proper financial effect. Your results might be deviating because all other sectors get into losses, only this sector make the money. So to apply stratified sampling, first we need to divide entire population into homogeneous groups. Then you can use random sampling within the homogeneous group. These homogeneous groups are called stratum. Calculate the proportion of each stratum within the population, means proportion for this one is P1, for this P2. Like that you have to calculate proportion within this population. Based on these proportions you can apply random sampling procedure and combine samples from each stratum to create final sample, means you will get some values from this stratum and some values from this stratum, like that. In final sample you have to include samples from all stratums. This is the final sample. Third one, clustered sampling. Clustered sampling also same like stratified sampling. This can be applied on non-homogeneous population. Here we need to divide entire population into different clusters, but selection of the sampling will be different here. In stratified sampling, you will select some proportion from each stratum and you will include that in final sample. But whereas in clustered sampling, some clusters will be selected randomly, might be this one and this one and this one. All the samples from these three clusters will be included within the final sample. Means if you want to study some COVID-19 effect on different sectors, you will consider only some most important sectors and you will consider samples from that sectors, means not from all clusters. If this cluster size is too long, you cannot include all the samples from this cluster, so you can apply random sampling within cluster and you can select some values from this cluster and you can include that in final sample. Major difference between stratified and cluster sampling is that in stratified sample, all classes will be presented in sample, whereas in clustered sample, only some clusters will be included in the final sample. Clustered sampling will be used when you have so many clusters, then you cannot include all the clusters. So you will select some of the clusters from them and you can use clustered sampling to select sample. Example, demonetization effect on Indian economy. You cannot conduct study on all the sectors within India to study the demonetization effect on Indian economy. Bootstrap sampling. It is also called as bagging. Bagging is sampling with replacement used in machine learning algorithms like decision tree and random forests, especially the random forests. In bagging, several samples with replacement are generated from population and models are developed with each sample. Used in ensemble methods, non-probabilistic sampling. In non-probabilistic sampling, the individual observations in sample does not follow any probability distribution. Samples are selected based on convenience or voluntary basis. First one, convenience sampling. Researcher may collect data from his school or from his workplace or from his friends based on his convenience. It is not recommended. Results may be biased. For example, if you want to conduct some study on school children in India, you cannot go to each and every school and you cannot take the survey. In convenience sampling, if you have school, then you can collect from that school, or if any of your friends have school, then you can use that school to collect the sample, but it will not completely represent the population, but it is cost effective. Second one, voluntary sampling. Data collected from people who volunteer for such data collection. Examples, customer feedback in retail stores, or if you take the movie reviews, when new movies released, TV channels will go to theater and they will take the review from the people who come forward and give their opinion. These kind of samples are called voluntary samples.